Good morning children. In the second part video, today we are going to discuss about some important concepts in air lesson as well as in atomic structure lesson, right? So first we will discuss about Dalton's atomic theory. John Dalton proposed the atomic theory. In that theory, he stated some important points. The first one is all matter is made of atoms. He said that atoms are indivisible and also it is indestructible. Indivisible, you know the meaning. We cannot divide it. Then what is the meaning for indestructible? Indestructible means not able to destroy. So this is the first concept in Dalton's atomic theory. So in Dalton's atomic theory, he proposed that all matter is made of atoms. Hence atoms are indivisible and also it is indestructible in nature. Right? Second one, all the atoms of the given element are identical in mass as well as in properties. This is the second property given by John Dalton. Third one, atoms are, already I told you, atoms are indivisible and all the chemical reactions, it is nothing but the rearrangement of atoms. Chemical reaction is the rearrangement of atoms. Next one, compound is made of two or more different kinds of atoms. So these things proposed by John Dalton. 4 points he proposed. One is atom is indivisible and also it is indestructible. It means we cannot able to destroy the atoms. Second one, compounds are made of combination of two or more different kinds of atoms. Next one, all the elements are made of atoms only and chemical reaction is the rearrangement of atoms. This is the Dalton's atomic theory. This is a very important theory proposed by John Dalton. Understood children? Right. Next we can move to anode and cathode. What is the difference between anode and cathode? First let me take anode. Anode is nothing but the positive electrode. The positive electrode is nothing but anode. Otherwise we can say it can accept the electrons. It is an electron acceptor. It means to accept the electrons. The positive electrode are called anode. Whereas if you take cathode, cathode is nothing but the negative electrode. Negative electrode is known as cathode. Negative electrode is known as cathode. Otherwise we can say it is an electron donor. Electron donor means what? It donates the electrons. So what is the difference between anode and cathode? Anode means the positive electrode is known as anode. We can say one more thing, one more way we can say about the anode. It is nothing but it is an electron acceptor, whereas cathode is a negative electrode is known as cathode and we can say it is an electron donor. So next we can move to subatomic particles. According to Rutherford, an atom consists of 3 subatomic particles. What are the 3 subatomic particles? Protons, electrons and neutrons. These 3 are the subatomic particles. Here, protons and neutrons are present at the center of the nucleus, whereas electrons revolve around the nucleus in circular path. So what are the subatomic particles? The 3 subatomic particles are protons, electrons and neutrons. Each and every subatomic particle, they have some charge. For example, if you take proton, protons have positive charge, whereas electrons have negative charge, and neutrons they have no charge. It is neutral in nature. Got it? Right. Next we can move to nucleus. Nucleus is the central part of the atom. That is, the central part of the atom is called nucleus. Okay. It consists of protons and neutrons. Got it, children? What is nucleus? Nucleus is the central part of the atom. Next one, orbits or shells. Orbits or shells. Okay, both have same meaning only. The electrons which revolves around the nucleus in circular paths are called orbits or shells. Okay, the electrons which revolves around the nucleus in circular path are called orbits or shells. Next one, valence electrons. You know about electrons. And what is meant by valence electrons? The electrons which revolve around the nucleus, that is, the electrons which revolves around the nucleus in the outermost orbit. Okay, the electrons which revolves in the outermost orbit are called the valence electrons. Okay, in the first orbit, suppose if an atom consists of 3 orbits or shells, means in the third orbit is the outermost orbit. In that orbit, suppose if 2 electrons are revolving, means we can say it will come under valence electrons. Okay, the electrons revolving in the outermost orbit are called the valence electrons. Got it, children? Right. Next we can move to electronic configuration. What is meant by electronic configuration? The arrangement of electrons in various shells of an atom of the element. This is called the electronic configuration. Okay, it's a very important 2-mark question. What is meant by electronic configuration? The arrangement of electrons in various shells of an atom of the element is known as the electronic configuration. Got it? Right. Next one we can move to valency. What is meant by valency? Valency is nothing but the combining capacity of an atom. Okay, the combining capacity of an atom is known as valency. Got it? So next one we can move to types of valency. What are the different types of valency? It has 2 types. One is the positive valency and another one is the negative valency. Okay, one is positive valency, another one is the negative valency. What is the difference between positive valency and negative valency? If you take the positive valency, the atoms which donate electrons are said to have positive valency. Okay, then only that atom will attain the stable position in the electronic configuration. Okay, atoms which donate electrons are said to have positive valency. Then what is meant by negative valency? Here the atoms which accept electrons, then only that atoms will attain the stable position. So it accepts the electrons. Okay, atoms which donate electrons are called positive valency, whereas atoms which accept electrons are said to have negative valency. Valency means what? The combining capacity of an atom is known as valency. It consists of 2 types. One is positive, another one is negative valency. Positive valency means atoms which donate electrons, whereas negative valency means atoms which accept electrons. This is the difference between these 2. Got it? Right. Next we can move to ions. You know very well, ions means atoms or group of atoms, they have some charges. It may have positive charge or otherwise it may have negative charge. These are called ions. Okay, atoms or group of atoms having a charge called ions. Okay, in the bracket you should mention the charges, positive or negative. That also you should mention it. Okay, there are 2 types of ions. Okay, one is a cation, another one is a anion. There are types of ions. One is cation and another one is anion. Cation means it is a positively charged ion. Okay, positively charged ion are called cation, whereas negatively charged ion are called anion. Okay, don't get confused. Ions means atoms or group of atoms having a charge, positive or negative charge are called ions. There are two types of ions. One is the cation and another one is the anion. Okay, and you should mention what is meant by cation means you have to mention. Cation is the positively charged ion, whereas anion is the negatively charged ion. Okay. Next we can move to chemical formula or molecular formula. Both have same meaning only. Okay. A chemical formula is a shorthand notation of a molecule. Okay. It actually shows the number of atoms which is present in the molecule of a substance. This is called the chemical formula or molecular formula. Okay. So what is meant by chemical formula? Chemical formula is nothing but a shorthand notation of a molecule, whether it may be a compound. Okay, shorthand notation of a molecule or compound. It shows the actual number of atoms which is present in the molecule of that particular substance. This is called chemical formula or molecular formula. Okay. Next one, chemical equation. Chemical equation is a symbolic representation of a chemical reaction by using symbols and formula. Okay. So, what is meant by chemical equation? Chemical equation is a symbolic representation of a chemical reaction by using symbols and formula. For a chemical reaction, we will use symbols, particular element symbol as well as formula we will use. Okay. So, it is a symbolic representation of a chemical reaction by using formula as well as symbols. Okay. Each and every chemical equation, it has two ingredients or two components. Okay. Every chemical equation has two components. One is the reactant and another one is the product. What is the difference between reactant and product? If you take the reactant, here a substance which takes part in a chemical reaction are called reactant. Okay. Reactant means a substance which takes part in the chemical reaction. Right? What is meant by product? Product means a substance which is formed in the chemical reaction. Okay. A substance which is formed in the chemical reaction are called product. Okay. What is the difference between reactant and product? Reactant means a substance which takes part in the chemical reaction. Finally, you will get one product, isn't it? A new substance will be formed during chemical reaction. That is nothing but the product. Got it, children? Okay. So, what is meant by chemical equation? A chemical equation is a symbolic representation of a chemical equation, a chemical reaction by using formula and symbol. Got it? Right. Next one, precipitate. Okay. What is meant by precipitate? During chemical changes, some substances react to form in the form of powdery substances. Okay, otherwise we can say precipitate is nothing but it is in the solid form. Okay, a precipitate means during chemical change or during chemical reaction, some substances react to form in the form of powdery substances. These powdery substances are called the precipitate. Got it, children? Right. So next one is laws of chemical combinations. Okay, laws of chemical combinations. There are 5 laws of chemical combinations. Okay, there are 5 laws of chemical combination, and these laws which govern the composition of the chemical composition, chemical combination of elements. Okay, what are the 5 laws? One is law of conservation mass. Okay. Another one is law of constant proportion. Third law is law of multiple proportion. And fourth one is Avogadro's law. Fifth one is Gay-Lussac's law. So all these 5 laws will come under the category of law of chemical combinations. In your book, 2 laws only given. The remaining laws you will be learning in your higher classes, right? First one, let me discuss about law of conservation of mass. Okay, Lavoisier proposed the law of conservation of mass. According to this law, that is according to law of conservation of mass, during chemical reaction, the total mass of the product are always equal to the total mass of the reactants. Okay, what this law actually says? Law of conservation of mass states that during chemical change or during chemical reactions, the total mass of the products are always equal to the total mass of the reactants. Okay, so this is the law of conservation of mass, and this law was proposed by Lavoisier. Got it? Right. Next one, law of constant proportions. Okay, scientist Proust proposed this law of constant proportions. According to this law, that is law of constant proportions, in a pure chemical compound, the elements are always present in a definite proportions by mass. Okay, the law of constant proportion states that in a pure chemical compound, the elements are always present in a definite proportions by mass. Okay. For example, you know very well water is obtained from different sources, isn't it? You know the different sources like river water, well water, tap water, ocean, as well as underground water intake. Okay. All the water, it consists of only 2 elements, that is hydrogen as well as oxygen. You know very well water is composed of hydrogen as well as oxygen elements. Okay, so whatever it may be the source, the water is composed of only 2 elements, that is hydrogen and oxygen in the ratio 1:8 by mass. Okay, here the mode of preparation may change, but the composition will not change. Okay, the mode of preparation may change, but the composition will not change. For any source of water, it is composed of only 2 elements, hydrogen and oxygen, in the ratio 1:8 by mass. Okay, the composition will not change. It is in the fixed ratio. Okay, hence this law of constant proportions, is otherwise known as law of definite proportions. Understood, children? So law of constant proportion says that in a pure chemical compound, the elements are always present in a definite proportions by mass. Yes. So we saw about the law of law of conservation of mass and law of constant proportion. Next we can move to nitrogen fixation. What is meant by nitrogen fixation? Here, in this process, okay, nitrogen fixation process that converts the nitrogen in the air into a useful nitrogen compound. Okay, this is called the nitrogen fixation. Once again I repeat, the process that converts nitrogen in the air into a useful nitrogen compound is called nitrogen fixation. Nitrogen fixation can be carried out by 2 processes. Okay, one is the natural way and another one is artificial way. For example, through the natural process, it is carried out by using leguminous plants and also by lightning. It is naturally occurring. Okay, and next come to the artificial part through ammonium salts as well Okay, so it's a very important 2-mark question. Nitrogen fixation means the process that converts the nitrogen in the air in the form of a useful compound. Okay, nitrogen into the air into useful nitrogen compound. This is called nitrogen fixation. It is carried out in a natural way as well as an artificial way. Next, we can move to sublimation. Define sublimation process. Sublimation is nothing but the process of converting the solid state into vapor state. Okay, conversion of solid state into vapor state is called the sublimation process. Example, we can say camphor as an example. Okay, sublimation means what? The process of converting solid state into vapor state or gaseous state is called the sublimation process. Next one, greenhouse effect. Okay, so what is meant by greenhouse effect? What are the different greenhouse gases? Let me see now. Trapping of radiation is absorbs. Okay, trapping of radiation from the sun by greenhouse gases in the atmosphere that leads to rise in the Earth's atmospheric temperature is known as greenhouse effect. Okay, once again I repeat, trapping of radiation from the sun by greenhouse gases in the atmosphere that leads to rise in the Earth's atmospheric temperature is called the greenhouse effect. Then what are the different greenhouse gases? Name the greenhouse gases. The answer is chlorofluorocarbon, methane, okay, nitrous oxide, chlorofluorocarbon, that is in short form we can say it as CFC, right, and methane gases. These are some of the greenhouse gases. This one you will get in the 1-mark question. Okay, 1-mark question definitely will come. The greenhouse gases you should remember. Minimum 2 or 3 greenhouse gases you should write. Okay, chlorofluorocarbon in the bracket you should mention CFC, all in capital letters. Okay, CFC is chlorofluorocarbon and methane gas. Okay, methane gas is also and nitrous oxide gas also. You can give example for greenhouse gases, right? So next one is about global warming. Global warming. What is global warming? This is also important question. The greenhouse effect is due to the increase in the air pollutants. Okay, greenhouse effect is mainly caused due to the increase in the air pollutants. It releases various harmful gases, isn't it? So, increase in the air pollutants and it results in the average rise of temperature of the atmosphere. This leads to global warming. Okay, I repeat again. The greenhouse effect is caused due to increase in the air pollutants and it results in the average increase of temperature of the atmosphere. This leads to global warming, right? And finally, we can move to acid rain and its preventive measures. So, what is acid rain? Generally, acid rain is caused by a chemical reaction that begins when compounds like SO2. SO2 is nothing but sulfur dioxide and nitrogen oxides. Okay, they released into the air. These substances mix and react with water, oxygen and other chemicals to form more acidic pollutants, and these acidic pollutants react to form the acid rain. Okay, what is the acid rain? Acid rain is caused by chemical reaction that begins when compounds like sulfur dioxide and nitrogen oxides are released into the air. These substances mix and react with oxygen and other water, oxygen and other chemicals to form more acidic pollutants. This leads to acid rain. So, what are the preventive measures that we have to take to avoid this acid rain. What are the things we have to do? First, we should avoid using fuels like petrol, diesel, like that. Okay, we have to move to some alternative source of energy such as tidal energy, wind energy, bioenergy, solar energy, like that. Okay, and also we have to use compressed natural gas, that is CNG. The CNG is nothing but the compressed natural gas. It is an alternative source of energy. Okay, it is an environmentally friendly alternative. So we have to go ahead with that alternative source of energy instead of using this water. Instead of using the petrol, diesel, like that, we have to move with compressed natural gas. It is an environmentally friendly alternative. Okay, and industrial waste, it should be removed in a proper way, right? So these are some of the steps we have to take to prevent acid rain. Understood, children? Okay. So what are the things we discussed today? Dalton's atomic theory, anode cathode, subatomic particles, nucleus, and orbits or shells, valence electrons, electronic configuration, valency, its types, ions and its types, followed by chemical formula and then chemical equation, then about the law of combination of elements. Okay, followed by acid rain, its effects, how to prevent, and then global warming, what are the gases responsible for greenhouse effect. These things we discussed today, isn't it? Okay, so go through all the things, children. In the next video we will see the remaining things. Thank you, children.